Radhe Radhe. So in this video I'm going to discuss the maximum total damage with spell casting which occurred in today's LEETCODE challenge. So if you have any doubt regarding this, ping me up on Instagram. Even you can join my Discord server. I'll put both the links in the comment section. I'll pin them. Problem statement is very simple. You're given an array. What you have to do is you have to find what is the total damage that can be done with that array. So what basically you need to do is you have to select all the elements from the array such that if you're selecting element x, then x minus 2, x minus 1, x plus 1 and x plus 2 shouldn't be there. Okay, clear? So for this, it is the optimal solution will be 4 1 1. Okay, so that is 4 plus 5 1 plus 1, that is 6. Okay, for this the optimal solution will be 6 6 1, that is 6 plus 6 12 plus 1 13. Okay, so now let's go into the logic. So if you're looking at this, you can say that it's a basic DP, and what the DP is doing is basically if you're taking DP, if you're at any position, if you're taking the element x, then you have to find x minus 1 you can't take, x minus 2 you can't take. So it is better you first sort the array. Okay, so step 1, sort the array. So once you're done with the sorting, then at every position I, find out what is the value of power I. Okay, and remember you have to find power I minus 3, because I minus 1 and I minus 2 you can't take. Since it is DP, so you have to just check the previous element. So I minus 1, I minus 2 you can't take, so find the last position where power I minus 3 occurs or anything lesser than equal to that occurs. Okay, so at whatever position that is you're getting, you can initially DPI. Okay, so let me write the recursive function. DPI is equal to power of I. Now if you find a position where the power of position where it is lesser than equal to power of I minus 3, so what you can do is you can make dp of I plus is equal to the maximum power that that position can generate. Okay, the maximum power that the position can generate, so that is plus. Okay, and remember one thing, since in this case you have seen that once there was a 6, so you can also take a 6. Okay, so what you can do is you can take another position, let's say this position, let me call it P. Okay, position equal. Okay, position equal. So position equal is the the first most least most position where it is equal to power I. Okay, so because you can take that also. So if you get the possec and I position, so you know that for pos I minus possec position, all the elements are equal to power of I. Okay, so you can multiply them and add to the dp. So that is dp of I plus is equal to I minus possec into power of I. Now how we are going to find the position or the possec position? We can use a normal binary search. Okay, and find it. So I hope that is clear. And how you are going to calculate this max power thing? So this is simply you can take a max power array of size n. Okay, just the way you are taking a dp size of size n, you can also take a max power array of size n. And while iterating throughout the whole thing, so initially you can take a element known as max p, make it 0. Okay, now for position 0 you can make max p is equal to power of 0. And while you're traversing from 1 to n minus 1, what you can do is you can make max p, max power, this would be max power. Okay, sorry. So max and max px, max p will be equal to power of 0 2. Okay, so both of them will be 0, a power of 0. Okay, and for everything what you have to do is max p is equal to maximum of max p comma dp of I. Okay, like after you're done with the whole operations, this is the last thing you have to do. And what you have to do, make is maximum power I is equal to, sorry, is equal to max p. And what is going to be the answer? The answer is going to be the maximum of all elements in dp. So let's go for a dry run. For this, if we sort the whole array, so it becomes 1 6 6 7. Okay, now what the maximum p looks like, it is initially 1. The maximum power, it would look somewhat like this one. Okay, 1 0 0 0. Since I told you this is going to be 1 by default, so since now it is sorted, so now we are going to traverse. Okay, so we are going to go for 6 and find what is the last element, that is 6 from this side. So it is this element only, so that is, let me write the position 0 1 2 3. So it is 1 only, right? So like, let me write it. So one is position and the other was pursuit. Okay, so what is the position? 6 minus 3, that is 3. So what is the last element that is lesser than equal to 3? That is 1, right? So this, what was max pos of this? It was 1. So what you can do is dp. Okay, so what the dp looks like, so this is what the dp looks like. It was 1 0 0 0. So when we are going to this position, we are just updating it as 6. That is this thing, dp of I equal to power of I. Okay, and once you are done with this, you have to make dp of I plus is equal to max power pos. Okay, max power pos is 1, so that is 6 plus 1, that is 7, right? Clear? Now we have to find I minus pos ec. What is I minus pos ec? It is 1 minus 1. Okay, because pos ec is 1 and this is 0. So 1 minus 1 is 0. So we don't need to perform anything because 0 into something will be 0 only. Okay, so now we go to this position. So it is 6, updated as 6. Then check, that is, this is 0 and this will be 1 also. Okay, like if you're traversing from here, the leftmost element that is containing 6 is 1. Okay, so 6 and then plus is equal to this position of maximum, that is 1. Okay, I forgot to update this, it will be 7. Okay, since always you need to update it, and this has become 7 too. Now so 6, so it becomes 7. And then for pos eq, that is 1. So 2 minus 1 is 1. 1 into it was power of I, so that is 1 into 6. So 7 plus 6 is 13. Okay, now you're going to make it 13. Now we are going for the 7, so update it as 7. So pos sec becomes 3 and pos becomes 7 minus 3 is, so 7 minus 3 is like not 6, it is lesser than 6, so it is still remains 0. So 7 plus 1, that is 8, and 7 plus 3 minus 3 into 7, so it becomes 0 only, so it remains 8. So the dp array looks like 1 7 13 8. Okay, so rewrite it, it looks like 1 7 13 8. So what is the maximum? It is 13. So what is the answer? It is 13. So I hope this is clear. That's it from my side. Thank you.